Welcome to this quick dive into understanding biases in machine learning systems. In this video, we'll unpack three primary types of bias that can influence the performance and fairness of machine learning models: historical bias, representation bias, and measurement bias. Let's start with historical bias. Back in 2014, Amazon built a model to review resumes with the aim of automating its search for top talent. Their experimental hiring tool used artificial intelligence to give job candidates scores ranging from 1 to 5 stars. However, by 2015, a critical issue came to light. The system wasn't evaluating candidates for tech roles fairly, particularly when it came to gender. Why? The AI had been learning from a decade's worth of resumes, predominantly from men, mirroring the tech industry's gender gap. The system had inadvertently learned to favor men over women. For instance, if a resume mentioned women's, like women's chess club captain, the system marked it down. It even undervalued diplomas from all women's colleges. Next, let's explore representation bias through a technology many of us use daily: automated speech recognition, or ASR. Think of the convenience brought to us by devices like Amazon's Alexa or the iPhone's Siri. They've changed the game for many, making multitasking a breeze. Yet, here's the twist: these innovative systems don't always hear everyone equally. A revealing study has brought to light a significant issue. These ASR systems are often less accurate for Black speakers. The voice recognition technologies from tech giants, think Apple, Amazon, Microsoft, and Google, showed a pattern. They were twice as likely to misinterpret words spoken by Black individuals compared to white individuals. And why is this happening? It boils down to the data these systems were trained on, which predominantly represents white speakers. This means a whole spectrum of accents and dialects, rich with their own linguistic nuances, are being overlooked. Consequently, Black speakers find themselves misunderstood by these devices twice as often as their white counterparts. Ultimately, representation bias arises when the data used to train a model does not accurately reflect the environment or population where the machine learning system will be deployed. It's as if you trained for a marathon on flat terrain and then had to race on a mountain trail. The conditions simply don't match. Now that brings us to measurement bias, a critical concern and one that is especially evident in the healthcare sector. Picture this. In the US, healthcare decisions are often guided by commercial algorithms. But here's a startling fact. A recent study uncovered racial bias in a commonly used health risk algorithm. Imagine two patients, one Black and one white, both with the same risk score. This algorithm would have you believe they require the same level of care. But the truth is starkly different. The Black patient is likely to be much sicker. This discrepancy means Black patients are systematically overlooked for additional care they desperately need by a staggering 50% or more. Why does this happen? Because the machine learning algorithm uses healthcare spending as a proxy for need. However, historically, less money is spent on Black patients with the same medical needs. So the algorithm mistakenly assumes that Black patients are healthier than their white counterparts who are just as ill. Measurement bias in machine learning systems occurs when the data used for training the model has errors in measurement that are systematically skewed in a particular direction. This type of bias is often introduced when the data collection instruments or procedures used are flawed. It can also happen if the data does not capture the true value or behavior of the variable of interest accurately and consistently. if a machine learning model is trained on hospital data where certain symptoms of a disease are underreported for a particular demographic group, the model may learn to downplay the significance of those symptoms for that group. As a result, the model's predictions or decisions may be less accurate for individuals from that demographic. In summary, biases in machine learning are like silent stowaways on the journey towards accurate and fair decision making. Historical bias brings the baggage of the past, representation bias narrows our worldview, and measurement bias distorts our perception of reality. Recognizing these biases is the first step in mitigating them.